All right, so now that you guys have had a little bit of notes on how to graph these functions, let's just go through a quick bunch of examples so you can see the easiest way to know how to do this. So let's start with just basic sine of x. So when I graph this, sine of 0 is 0, so it starts at the origin. So you should make a note that sine starts at the origin. Okay, and so the next step you're going to do is you're going to move over the period, because you know it's going to start repeating for whatever the period is. Now the period of regular old sine of x is 2 pi, because in a unit circle, when you go that full circle, you know that you are ending up back at 0. So I'm going to move over here. Let's call that 2 pi. And then the next step, I don't know why I'm doing asterisks, deal with it. Halfway in between 0 and 2 pi is another x-intercept. So halfway between 0 and 2 pi would be pi. So that is another x-intercept. So these are your 3 x-intercepts. Okay? So then you're going to do the halfway points again. And these are going to be your max and your min. So halfway between 0 and pi is half of pi. And I'm going to go up to my maximum. And with regular old sine, the amplitude is 1. So we can make a note of the amplitude being 1. I also wrote down that the period was 2 pi. So that means that this is going to go up to 1. That's my maximum. And then halfway in between here, that's at 3 pi over 2. I'm going to go down to my minimum. And then I'm going to draw the sine curve, the sinusoid. And that is one period of sine. Now, you can see here, you know that it's going to just continue like that. And so the one thing you want to be careful with drawing sine is that when you draw the curve, you know you have those 5 points. Oh, and these are the 5 key points. There we go. These are your 5 key points. Start at the origin, move over the period, halfway in between you put an x-intercept. Then you go halfway in between up to the max and down to the min. Those are your 5 key points for one period. But when you go to draw the curve, make sure that it doesn't look pointy. I don't like to see pointy sine graphs. Okay. The trick to drawing a good sine graph is that as you're heading into the maximum, it's leveling off. So you're almost heading into it horizontally. And the same thing with the minimum. When you are approaching this, you're heading in horizontally. Okay. So the maxes and the mins are coming in it horizontally, and so you don't get a pointy, you get a nice curved maximum. All right, so that's the basic idea for sine of x. Let's do a little bit more complicated one. So let's do f of x equals 2 sine of x. Okay, so for 2 sine of x, a good thing to write down is the period. Remember, to find the period in the notes, you wrote down that it was 2 pi over b, and b is the number multiplied by x. In this case, there's a 1, so it's 2 pi over 1. The period is, I can spell, the period is 2 pi. You should also find the amplitude. The amplitude was the a value. This is the number multiplied by the sine function. In this case, it's 2. So the amplitude for this example is 2. So we start the same way we did in the last one. You start at the origin, move over the period, which is 2 pi, halfway in the middle, which is pi, halfway in the middle up to the maximum. Now in this case, the maximum is going to be the amplitude, because the amplitude, if you were to define amplitude, the amplitude is the distance from the x-axis to the max or the min. Okay, Don't worry about that little scribble there. I edited something out. All right. So we want to go up the amplitude, so that means we're going to go up to 2. And so the maximum, which is halfway between 0 and pi, is up to 2. And then halfway here, that's going to be down to -2. And I can draw my curves. When this gets a little steeper, it's harder to draw them not pointy, but just remember to go in horizontally, and you get one period that is not pointy, and you can draw one period of sine. All right, moving on. I'll go through all my paper tonight. All right, -1/2 sine of x. So again, b equals 1, so the period is 2 pi. The amplitude is 1/2. Now, be careful here. The amplitude is always a positive number, because the definition of the amplitude is a distance, and distances can't be negative. So the amplitude is the positive number. But we don't just ignore that negative. The negative is going to cause there to be a vertical flip. So we'll see how that comes into play when I go to graph it. So just remember that that's there. All right, so let's set up our graph. Start at the origin, move over the period. Halfway in the middle is our third x-intercept. Then halfway in the middle, halfway in the middle. So these are the same numbers we've had the whole time because I haven't changed the period yet. Then we go up to the maximum, down to the minimum. But instead of going up to the maximum like this, because of the vertical flip, we're going to go down to the minimum and then up to the minimum, the maximum. And there's our one period of -1/2 sine of x. Okay, so if there's a negative out in front, the amplitude's still positive, but there's a vertical flip, which means you start out going down. Okay, let's do another one. I'm just going to turn this paper around and save some paper. Is that going to bother you guys? Here, I'll move it down a little bit. There you go. You can't even see it. All right, next one. Sine of 2x. Aha. So in this one, the b value is 2, which means that our period here is going to be 2 pi over 2, which you should be able to simplify. Cancel those out like a good Caps and Bellows student would do, and get pi. The amplitude is the number multiplied by sine. That's just a 1. So now when we go to graph it, start at the origin, move over the period. So typically we'd go on to 2 pi, but we're going to go to pi, because that's the period. Put our second point. Halfway in the middle, we're going to put our third x-intercept. And then halfway in the middle of each of those, and those numbers would work out to be pi over 4 and 3 pi over 4. Right, 3/4 of pi. We're going to go up to the amplitude and down to the amplitude. So I'm going to go up like that, like that. And you can see hopefully that multiplying by 2 on the inside is a horizontal shrink. So it shrinks it down instead of being like this. It shrunk it down, so it was like that. So that is sine of 2x. All right, next, let's do f of x equals sine of 1/3 x. Okay, so the amplitude here is 1. The period is 2 pi over b, so 2 pi over 1/3. And that is something that you should be able to simplify. A little help from our buddy Mr. 1. I would yell it, but I don't want to scare my family. These cancel, and you get that the period is 6 pi. So, when we go to graph, put a point at the origin, move over the period, which, we could just kind of 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. I'll call that 6 pi. Halfway in the middle is the other x-intercepts. You do 3 x-intercepts. You start at the origin, move over the period, halfway in the middle. Then halfway in the middle of those, we're going to go up to the maximum and down to the minimum. Now, you might be curious as to what that number is. So let's think about it. This was half of 6 pi, so 3 pi. This is half of 3 pi, so 3 pi over 2. And then this would be, what would this be? This would be 3 pi plus another pi and a half. That is 7 pi over 2. That doesn't seem right. 9 pi over 2. So then we put our up to our maximum because it's positive, down to our minimum. Should label those as 1 and -1. Draw my graph, so I'm going horizontally into, oh, that was horrible. Horizontally into, and like that. And you can keep in mind that if this was regular sine, this would have been 2 pi, so I would have gone there, there, up to there, down to there. It would have been like this. So multiplying by a number smaller than 1 is a horizontal stretch, so it stretched it out like that. All right, let's do uno mas of these, and that should be it. Let's kind of put everything together. So let's have f of x equal -3 sine of 3 halves x. All right, so the amplitude, always a positive number, is 3. The period is 2 pi over 3 halves. Mr. 1. Let me get that this is 4 pi over 3. And then we should also note there's a vertical flip. All right, so start at the origin. We're going to move over 4 pi thirds. So the way I'm going to do this is I'm going to pretend like I was going to 2 pi. I'm going to find pi in the middle. Then I'm going to cut this up into thirds. So that's 1/3 of pi, 2/3 of pi, 3/3 or a whole pi, 4/3. I'm going to put my end of the period. Halfway in the middle would be there, because that's 2/3 pi and that's 2/3 pi. And then I'm going to go 1, 2, 3, 1, 2, 3. So I should go up to the maximum, but there's a vertical flip. So I'm going to go down to the minimum first, up to the maximum. And it's going to look like that. That is one period of this function. All right, so just to recap the way you're going to go about doing these, you're going to start by graphing the point of the origin. Then you move over the period. And then you're going to find the middle of that. That does not look like the word move. Halfway, and these are your 3 x-intercepts. Okay, so halfway. And then you're going to find halfway points again. And those are going to be your maxes and mins. If it's a vertical flip, obviously you're going to switch those. And these are going to be your 5 key points. And then you draw your curve. All right, so on any problem that I give you, to graph a sine function, you must graph those 5 points. Like, I need to see clear dots. And you should have, obviously, if you're drawing your axes, because you're not using graph paper that I give you, you need to label, what these numbers are so that it's clear to me that you understand where the amplitude is, where the period is. One more thing about the period, just, I could have ended the video there and that could have been all I wanted to do, but I thought I'd bring this up. The period is the smallest amount, or the smallest distance before a function repeats. And we've been starting it at the origin and moving over the period, but I could have started here, moved over the period, and you can see that shape there kind of looks like, I don't know if you can fit this on, like that, also repeats over and over again. The period can actually be at any point, the period is just a distance. It's just saying that this distance is 2 pi. So 2 pi past this point is going to be the same y coordinate. It's going to start repeating the graph. Okay. All right, so that is our overview of graphing the sine function with amplitudes and periods that are not just one. So in your homework, you will be practicing that. Thanks, guys.